Welcome, everyone. I'm Dick Deming. I'm Medical Director of Mercy One Cancer Center and the founder of Above and Beyond Cancer. Welcome to our weekly cancer education series. It's brought to you in part by a grant from the Iowa Oncology Society. And our guest tonight is Dr. Mark Burkard. Welcome, Mark.
Thank you. Thanks for having me tonight.
Dr. Burkard is an MD and PhD, and he is the director of the Holden Comprehensive Cancer Center at the University of Iowa, one of the NCI designated comprehensive cancer centers. So we're going to talk about being a director of the Cancer Center and what's going on at Holden Cancer Center, and also what's going on in terms of cancer research and other advances to help reduce the burden of cancer. But before we do that, we're going to get to know you as a human being as opposed to just a doctor.
Thank you. That sounds wonderful.
So where are you from originally, Mark?
I grew up 20 minutes from Niagara Falls and outside of Buffalo. I come from a family of 8. I'm the 7th of the 8.
Oh, wow.
And I'm the only physician among them. Very different careers and trajectories.
So what's the age span of the oldest sibling to the youngest sibling?
Oh goodness. So it would be the youngest would be 51 and the oldest would be 65.
Okay. So about 14 years.
Yeah.
So you had some really quite a bit older brothers and sisters.
Yes, that's right.
So so not quite the youngest, but did you get special treatment being like having older brothers and sisters?
Well, it depends who you ask. You know how it is in families. Like the older ones thought that me and my younger brother had very special treatment, but we pointed out we had all the hand-me-downs from them. So we had the old raggedy clothes that they grew out of.
Yeah. And then how big of a high school did you go to?
Oh, we had about 1,200 students in the school, so it was a pretty decent sized school. Yeah.
What would you say your claim to fame was in high school? Or what would others say your claim to fame was in high school?
Oh, gosh. I guess I was a nerd who played hockey, but not very well.
All right. So in the room here, we have a hockey player who's still playing at age 60, and he's so he appreciates that.
Yeah.
And so you had high school high school as a regular sport, hockey.
It was a high school sport. Yeah. They let me play. I was kind of like the bruiser in the corner, but I couldn't score a goal.
The bruiser so you were like the enforcer that you had?
Well, I didn't push it that far, but
okay.
But I like to be a little physical.
Okay. And then where'd you go to college?
So I went to SUNY Buffalo, so the State University of New York. It was, close to home, and yeah, so that was and there I had a wonderful experience, Dick, because I was in the honors program and I met a professor of physiology who wanted me to be his editorial assistant. So I signed up to do that. And then he really took me under his arm and we started to do physiology research on an old Mac Classic computer that he programmed in BASIC.
Nice. I actually still have my very first computer, which was the Mac. I got it during my residency in 1984. Yeah, I still have.
Oh, that's an original.
Yeah. So did you know when you started college that you wanted to go into medicine?
Not really. I mean, as a child, I thought I had the idea of maybe I'll be a doctor or an astronaut. And then by the time I got through high school, I liked all the science classes. I was that nerd person. And then in college, I did math and physics. But the physiology professor really took me under his wing and said, you could do medical research. And so that really got me started on my career.
And then where did you go to medical school?
So I applied to the MD PhD programs. I went to University of Rochester, which didn't wander far from home at that time of my life. So
Yep.
I was
And for those in Iowa, we need to point out that's Rochester, New York,
correct.
not the more famous Rochester for the upper Midwest, which is in Minnesota. So Rochester, New York, was where you got your MD, PhD. So even the concept of applying for an MD, PhD program. So your mentor in college
He
encouraged.
really took me under his wing and was one of those people who kind of had a big impact on my life and career.
Mhm. So, what is getting a combined MD, PhD like?
Well, it takes a while. It's typically 8 years, so a lot of life happens. And during those 8 years, I got married and had my first child. So, like, life moved on. But the way that most of those programs are structured is you do a couple of years of medical school, then you go to a lab and do a right like a grad student, you complete your PhD and then finish medical school. And many universities have a NIH funded program for that because the vision for that program is if we have physicians who know how to do science, they would be on the forefront of applying scientific advances to make medical advances. And we'll come to this probably later, but later in my career, I got to be the director of such a program, which was an
Oh,
honor to mentor students
wow.
in that type of training.
So, when you were in your MD, PhD program, what was your research project?
Well, I didn't know what I wanted to do, so I was like a math and physics person. So I thought, gee, I'll do engineering and imaging science, and rotated in a couple laboratories, and didn't they didn't really speak to me. But then someone said, well, there's this chemistry laboratory that is looking at how these nucleic acid structures fold up and all the thermodynamics, and you could do well there. And I ended up joining that lab. I did a degree in chemistry, was the PhD. But when I was there, the Human Genome Project was just coming online, and so the vision was that how are we going to take all this information about the Human Genome Project and apply it to make a difference in medicine? And so my concept was if you knew how the nucleic acids folded up and you could turn them on and off, you could control cancer. And so I started going to oncology clinics and learning about cancer and the clinical application. And what I saw in oncology clinics was had nothing to do with the molecular stuff I was studying. It was all like, well, this chemo, causes this damage, this chemo. But one of my foundational experiences there was I was in those clinics just as Gleevec came out, and that was the first, I would say, molecular medicine available.
Mhm. And for those who may not know, most of our audience are cancer survivors and caregivers, lay caregivers. Explain what Gleevec is and why that was such a different concept compared to traditional chemotherapy.
So with traditional chemotherapy, what people did is they found, you know, chemicals that could destroy cancer cells in the lab, and most of them simply caused enough damage that cancer cells died more than normal cells. And so you could give those to people with a lot of toxicity to improve cancer. Gleevec was the first drug that targeted a very specific um, genetic problem caused by cancer. And that genetic problem was found in the 60s, but it was found because it was a relatively straightforward in that everyone with a certain type of chronic leukemia had the same genetic alteration that was unique to the leukemia cells. And you could see it just looking at chromosomes under a microscope. So over the years, people slowly discovered that that cancer was caused by two genes on the chromosome that came together that shouldn't have been together, and they made a protein that had pieces of both, and that generated a signal in the blood cells that caused them to not mature and turn to leukemia. So what the Gleevec did, it was the first genetic treatment for cancer, and you took a pill and it would turn off that signal.
And isn't it true if, that it was engineered specifically? I mean, you knew the target, and then in the lab, they created the drug to specifically address that target?
Correct. That's exactly it. So that was a revolutionary change in oncology. Before that, it was very empiric, meaning, this molecule works on cells in the lab, so let's give it to people and see what happens. And some worked and some didn't. So you didn't have much logic to it. But now with Gleevec, you went to, hey, we understand what's driving this cancer. It's a signal from this abnormal protein. And if we make a molecule that turns off that signal, then we can treat cancer. So it was really a revolution.
And by some definitions, maybe the first targeted therapy, if you don't include sort of anti-estrogens or androgen deprivation as targeted, but
Right.
the first created. So that was really exciting. And that happened when you were in your MD PhD program, that Gleevec
Right. At
was
the end of medical school. And I was, again, I was excited about that because we are going to using our understanding of how cancer works to actually improve the care. And it, as you know, Dick, it profoundly improved the lives of people who before that would get a bad chemotherapy. They'd have a chance at a bone marrow transplant, which in the type in those days, 80% of people made it with a lot of complications, but 20% of people didn't even make it through the process. And by contrast, that pill transformed that disease to one that could be suppressed. Now, it wasn't perfect. It didn't cure the cancer, and people had to continue to take it. But it replaced a bone marrow transplant with one pill a day.
Yeah, exciting. And would you say that finding happening when it did was a big influence in you becoming a cancer doctor? I mean, because as you said, you were physics and math, which easily could have led to a radiology career or
Yeah, I could have headed your way, but I got derailed by this
by Gleevec.
by Gleevec. Yeah, and I was thinking like the future of one of the exciting opportunities of the future of oncology was controlling specific genes that were driving the growth of cancer, and so I was thinking of that as I was doing my chemistry PhD, and then there I saw it in the clinic.
Okay. So 2 years of medical school, then 4 years getting your chemistry PhD, and then 2 years of your clinical rotations. And by the time you started your clinical rotations, your last 2 years of medical school, were you pretty well set on oncology as your path?
Yeah. So by then I knew because I had experience, those experiences in the clinic, those experiences in research, and I saw a a bright future of how we could make remarkable improvements in cancer care.
So then on to internal medicine residency. Where did you do that?
So I moved on to New York City. So I was in the Upper East Side of Manhattan and went to Cornell New York Hospital.
Okay.
And I was on a research pathway. So I had 2 years. And in that time, you had to apply for fellowship, oncology fellowship, a year and a half ahead, or almost 2 years ahead. So I started my internship in June and applied for fellowship in August.
And your fellowship was where?
It was at Memorial Sloan Kettering Cancer Center in New York. It was almost across the street from
Okay.
Cornell. So it was all right there.
And did you continue to do research during your residency and fellowship?
So during residency, it was very clinically focused, but I was on the research pathway. And what that allowed me to do is enter fellowship a year early and to spend a year longer in fellowship. So the total time of residency and fellowship is about 6 years. And so in the third year of those six, I entered fellowship in very clinical focus on how to do medical oncology at Memorial Sloan Kettering. And then the last 3 years, according to that training pathway, I did most of my time in research and one clinic a week. So a lot of laboratory experiments. And I
And
was
then,
interested in like targeted medicine. Well, like what's the next one? So that's where I ended up.
okay. When you finished your fellowship, what was your first position outside of a training role?
So by then, my wife and I had 4 children in Manhattan, and we said, let's move on to the Midwest. So I applied to several places, but ended up at the University of Wisconsin as my first faculty position.
Great. And was your wife from New York, or where did she grow up?
She grew up in Manila, so she's
Oh,
from overseas. But
okay.
she has an interesting story. When her mom worked for World Bank, she moved from Manila to London, Ontario, and started did college there, and then we met in graduate school at University of Rochester.
Okay. And so how was moving to the Midwest, to Madison, Wisconsin?
Well, we didn't have a lot of space in New York, and my son was watching Blue's Clues, if you remember that show. I don't know. And he was excited because we had a mailbox that looked like the mailbox on Blue's Clues for the first time. And there was this green stuff on the ground that you could walk on,
You're right. Which became white.
which
It's
turned white very quickly. Yes, brown then white.
great. Great. And how long were you in Madison at the University of Wisconsin?
About 16 years.
Okay. So your kids grew up there and probably think of that as their home as during childhood.
Right. My children grew up there. 3 of my children either went to or are at university there.
Okay. Um, and I assume that you continued doing research. So as you come on as the first year faculty at the University of Wisconsin Carbone Cancer Center, you're doing both seeing patients and you're doing research and trying to find a balance, or do they direct kind of what that balance is, or do you have a lot of uh, choice in what that balance will be between seeing patients and doing research?
Well, when I came in, I asked to see patients, to 1 day a week. And the reason that that was acceptable is because clearly I was on a track of doing research and could apply for, federal grants to support that research. So they had to be convinced that I would have some level of success to offer me the space to do that. But they had just built a new research building. So they were looking for someone doing breast cancer laboratory research. So it was a good opportunity at that time.
And Mark, when did your field of interest from a research perspective turn to breast cancer? Was that during your fellowship or?
During fellowship, yeah. While I was in fellowship, the EGFR inhibitors came out for lung cancer. And so that was kind of another example of molecular medicine. And the HER2 drugs came out for breast cancer. So this thing about Gleevec was starting to repeat more and more.
Mhm.
But breast cancer seemed like there were more opportunities to do research to find newer targeted therapies.
And then over the course of your 16 years at the University of Wisconsin, how did your career change? I think you already alluded to the fact that you helped create or at least lead an MD PhD program there in Wisconsin.
Well, I had this problem, Dick. I didn't say no to a lot, which is part of the reason I'm here tonight. Actually, I'm having a lot of fun talking to you tonight. Um, so I would just do things. So I was seeing my patients. I was getting my lab set up. I'd find some grad students that we were working on, and then the director of the MD PhD program said, Mark, would you like to do this? And so I found myself on their admissions committee, and then couple years later, they said, Mark, would you like to be the associate director? And so I got involved in that. And then a few years later, they're like, Mark, I'm done. The director was like, I'm done doing this. Would you be the director? And so I didn't say no to any of those things.
Uh-huh.
So I ended up, but I really enjoyed working with there were 80 students in the program, about 10 per year times 8 years. University of Iowa has a similar size program. And everyone has their own ideas and personalities. They get to learn a lot about working with people when you have 80 students at some level, depending on you for mentorship support. Not their sole mentor, they're all in different labs, but
Mhm.
and it was hard to leave because of that. They gave me this poster behind me when I left, so that was my gift from that.
Yeah, that's beautiful, and that's the campus there in Madison.
Right.
Um,
But
but
now I'm an Iowa guy, so
yep.
total convert, except for that's for the students.
So let's just a good transition. So we'll move to Iowa. So you became the director of the Holden Comprehensive Cancer Center about October 1st. Is that right?
Correct.
Uh-huh. And what what made you think that you wanted to be a director of a comprehensive cancer center?
Well, following on the trajectory of what we talked about precision medicine, what happened when I was at the University of Wisconsin is there were new technologies coming into the clinic. And unlike the simple gene that caused that leukemia for Gleevec, what people were finding is all the other cancers were complicated. But you could deal with that complexity if you use DNA sequencing technology on every patient's cancer. So what you found out is unlike that leukemia, every breast cancer was a little bit different. But you still could use precision medicine if you knew, each patient's genes. And so when I was doing that, I said, gee, we could help a lot of patients if we could coordinate this precision medicine approach across our whole hospital. And then I said, my colleagues and I said, could we do more if we collaborate and do it across the whole state? And so we developed these collaborations across the state. And what I found was by collaborating with many people, trying to make things as seamless as possible, and working with actually some drug companies that had developed these really clever new medicines for specific genes, we could help patients. So for example, there was this one patient who came to our clinic, I think in 2017, and she had a very difficult situation. She had a type of a tumor called the GI stromal tumor, and the doctor said, well, there's 99% chance that we have a targeted pill for you. And, she got that pill, and the tumor didn't shrink. It kept growing, which is very unusual in that disease because usually that targeted pill targets the gene. But what they hadn't done is found the right gene for that particular person. And so when that was applied, they found it was a very rare gene called NTRK or NTRK that was driving the growth of that cancer, which happens maybe in 1 in 1,000 of these. And so once we learned that, we were able to get her the right medicine. And she went from very sick, almost dying from cancer with a soccer ball sized tumor in the abdomen, to that tumor shrinking over 6 months to nothing visible and taking one pill a day. And I left a few months ago, but last I heard she was doing fine. So, they're amazing. So by delivering this program regionally, you could profoundly impact people's lives. And and that got me excited about what I could do more than I just in my lab or in my clinic.
Yeah, but you still have a lab, and do you still have a clinic?
I still have a clinic and I still
Yeah.
have a lab. The lab is a lot smaller since I moved.
Mhm.
And my goal for that isn't to grow it or to have a large lab, but to work with other faculty and develop collaborations.
Mhm.
And I still see patients with breast cancer or other cancers when I need to help out.
Right. So, you're a cancer doctor seeing patients one on one. You're a researcher in a lab, and you are an administrator in charge of what's your budget? I mean,
I don't know.
well, let's say it's hundreds of millions of dollars, and you're the boss. Those are very different skill sets. And I'm curious, as a human being, uh, do you feel like your skill set is better adapted to one of those three jobs, or are you just such a renaissance person that you really can do it all?
You're reminding me that I don't say no enough. And that is one of the striking things coming to Iowa is it's very different setup from the cancer center in the University of Wisconsin, in that the cancer center does run the clinical operations here, which I was both excited about, but it's daunting. So I would say, there are challenges, and things that I am not wholly prepared for. I'd like to be the Renaissance man, but I have challenges. But the fortunate part is I have very good partners
Mhm.
who lead and are important components of the research aspects of the cancer center, and then the clinical aspects of the cancer center. So I don't have to do it all. I mean, one thing
Right.
I've learned over the years is to work with really good people and rely on them, trust them,
So you don't like to have to
delegate.
personally negotiate with unions or
No, that's a level that I'm not prepared for.
okay. um, but back to if you had to rank how much personal joy you get from, and I'm just saying you've got three jobs, you probably have seven more, but if we just said you're being a doctor one-on-one with a patient, being a researcher in a lab, or being an administrator, how would you rank those in terms of personal joy?
I think what ultimately gives me joy is to have an impact on people with cancer. Cancer is a hard problem. It afflicts, as you well know, many people. It takes many lives. I've lost a lot of patients. I recently lost a close family member. And what gives me joy is to have that opportunity to have an impact. And I think of those three components as having it in a different way. When I'm in clinic with a patient, it's very tangible and real and direct what you can do for your patient. But it doesn't necessarily reach beyond that person and their family. And so I think about, what are we doing for the future to build for the future? In the laboratory, I have an opportunity to mentor new scientists, and make discoveries, but the pace is very slow. Sometimes I wonder if anything I've done in the lab, like, when is that going to have an impact on the patients? And as an administrator, that kind of fills that gap, like I explained about the precision medicine, about finding that one patient in a dire circumstance that, you know, the the new revolution of precision medicine can let us help. So I guess I value all of them in different ways. I always enjoyed, and I think you're like this too, because you do survivorship and above and beyond, and you're here tonight and you're seeing patients. So, it's different ways of having impact that are
Mhm.
meaningful and kind of fit together as a
Yeah,
whole.
yeah. Oh, let's talk about what you're excited about at the University of Iowa Holden Comprehensive Cancer Center in terms of not just your research, but the research of your colleagues and the students. And so maybe start with that. And now that you have been there for 4 months or so, what excites you most about the University of Iowa?
Well, a couple things. One, I have very wonderful colleagues who are really making meaningful differences in cancer. We have very strong researchers, multiple, so I'm not going to name them, in the areas of neuroendocrine cancer and sarcoma, both physicians and scientists, and physician scientists. We have, a remarkable College of Public Health with Mary Charlton and Natasha Askelson, who are leaders in the Cancer Center. They help us in outreach to the our catchment. So every cancer center has an area of service where we try to be the helpers in all aspects of cancer. And one thing Mary and her team found was that as of recently, we are number 2 in cancer rates among the 50 states. And we are looking into every opportunity we have to make a difference on that. So the things we're doing are, under Mary's leadership, is we're assembling a blue ribbon panel. We are looking for opportunities to reduce some of the risk that underlying the high rate of cancer. And she is reaching out and hosting a community event in each of 99 counties of Iowa. And that's a big task over the course of the year. But again, it's something I'm very excited about, and I have the opportunity to be part of some of those events.
I hope you guys are letting her use like the university airplane.
We're using the Zoom airplane in some cases.
Oh, okay.
Yeah.
Well, you're right.
But she said, I don't remember where it was, but a very rural county, there was a very large audience to hear about what their particular rates are of different types of cancer and what they can do about it. So that's very encouraging to get that level of engagement.
Yeah, she's a tremendous leader, and that finding of Iowa being second has really taken off in the public and the press, and really generating a lot of interest into doing a deeper dive as to why. And as you know, I mean, cancer is a reportable disease, and so we've got great statistics and can say in each county how many new cases and how many deaths, and it becomes quite personal when you divide Iowa into 99 counties and you've got good data.
Absolutely.
Yeah. What else going on at the University of Iowa that excites you, either individual research or I think you're building a new research building.
Right. So one of the opportunities we have is to grow our research programs and to be sort of future looking at what programs we are going to invest in to build for the future. As I talked about, the discovery of targeted drugs in 1999 was based on the discovery of genes in 1960, and the way you make progress is you got to understand more about the basic biology of cancer. So we're looking to make investments by recruiting bright young research teams in cancer immunology and artificial intelligence, informatics, and biomarkers as 2 areas that are very future looking in cancer. And that's only possible if we have the space to house those new researchers. And so one of the opportunities we have is with investments from the university is to build a new research building to house them.
Okay. And in cancer in general, so not limiting it to what's happening at the University of Iowa, what are you most excited about? It seems to me like the last 10 years, really, immunotherapy has gotten a lot of emphasis. What do you think is the next thing? Is there a next thing that's going to get a lot of emphasis with research that you think might have as much potential or more?
Yeah, I think looking forward, we're seeing a lot of progress in several types of new medicines. I'm a medical oncologist, so I'm a little bit focused there. And I put this, remember the war on cancer started about 52 years ago. And so we're 52 years into this thing, and I feel like we're materially making progress through understanding cancer. And we're at this point where people like Jimmy Carter, who had metastatic melanoma to the brain lived to 100, lived more than 10 years later, which would have never happened when I was a medical student. Looking forward, there are new types of ways to engage the immune system. There are special types of antibodies called bispecific antibodies that can be engineered to bring two things together. And one of the opportunities to bring together is in an immune system cell that can fight cancer to bring it to the cancer cell. And so that is those bispecific antibodies are one area that is poised to make major advances. Another area are antibodies that have a chemo drug attached to them. So instead of giving chemo generally, it's delivered more precisely to cancer. There's a new set of targeted therapies that address a problem that we had trouble in the past. Most targeted therapies turn off an enzyme, but that's all they can do. And some genes that cause cancer are not an enzyme you can turn off with a pill. So some of the new ones are called protats, which are molecules that cause that target to be degraded and turned off in a different way. So that opens up many other possible ways of getting targeted therapies and immunotherapies. So, I mean, we are on this journey. I'm very passionate about clinical research, as you may know, because we are replacing the drugs of the 1970s with the drugs based on the discoveries that we've made in the past 10 years. So I try to describe this to my patients of we're doing this clinical trial because our standard treatments are stuck in the Superman phone booth age, but now we're in the cell phone age, and we have to replace those standard treatments with the modern treatments.
Yeah. Some of the things you mentioned I had not heard of yet, so I really appreciate that. What do you think some people are excited about what we call theragnostics, or intravenous radioactive isotopes attached to kind of a targeted molecule that takes them to the cancer cells. Do you think that represents a bright new future, or is that just kind of tweaking radiation in a not so novel way?
I think that is an opportunity for the future. So there are a number of theranostics that have come into clinic, but it's similar. What you want to do is deliver a toxic therapy to the cancer and not deliver it to the healthy cells. So in principle, using something like an antibody that can accomplish that is ideal. And you could deliver. I mentioned a chemo drug, but a theranostics is often using an antibody to deliver a radioisotope. So it's a way of being precise with your therapy. I
Mhm.
would say, those drugs aren't as precise as we would like, whether it's delivering chemo or theranostics, but it is showing improvements for very specific patients when we have a good target to
Mhm.
deliver it to.
Okay. Let's shift gears to what we might call cancer control, which is more than just killing cancer cells. I mean, in terms of preventing cancers that are preventable, early detection.
Mhm.
Perhaps you might want to talk, if you want to say anything about multi-cancer early detection blood tests, or talk about cancer control as it relates to the inequity that we see with certain populations. What in terms of cancer control are you interested in addressing as the director of the University of Iowa Comprehensive Cancer Center for the state of Iowa?
Well, I mean, first of all, I'm interested in delivering a clear message about what we know, and then acknowledging what we don't know and the relative importance. And then I can come back to multi-cancer early detection tests. But people are asking, why are we number two in cancer? And that is a hard question to answer because a lot of people have a hypothesis about it. But when we look closely at the data, what we see is specific regions of the state have specific rates of elevated cancer, and they're different. So we conclude from that it's not one thing that's driving the high rates of cancer, it's multifactorial. And then if you look at the things that are cancer cause cancer, there are many things known to cause cancer, but um, they have different influences on the risk. And what is clear from the data and from what we know is, tobacco is still the number one cause, the number one contributor to cancer that we can have control of. Now, there are a whole bunch of other things we don't have control of. We get older. That causes cancer risk. There are um, other things that can modulate your cancer risk. I'm a breast cancer doctor, so for example, a woman choosing to have their child later is a life choice that you make, not for cancer risk, but we know that's related. But the things that you control, smoking, obesity, exercise, alcohol, it's something I think you also need to focus on in survivors, as you're doing, of how can we be more active and more physically fit. So I think getting that message out there is important. It's okay to have other hypotheses about other environmental causes, but I would say if those causes had an impact equal or even close to tobacco, the data would be crystal clear.
Okay. And is there research going on at the University of Iowa or in Iowa looking specifically at environmental causes? And obviously we're in a state where the agricultural industry is huge, and when you look at the amount of chemicals that are distributed across the land, obviously many people have that as a hypothesis as one of the contributing factors. How do you even go about designing a study when there are so many different chemicals that may be carcinogenic in different amounts? And how do you do that? It seems like, back in the days of proving that cigarette smoking caused lung cancer, you were dealing with kind of one entity, and you
Right.
were doing the
Clearer.
research kind of with one cancer. Obviously, cigarette smoking causes other cancers, but it was kind of clear that relationship. I'm just trying to put my head around how would one conduct a study that reaches a p-value or clinical significance that the everybody accepts as the smoking gun, if you
Right.
will.
It's challenging. And as you say, if like things have more minor impacts, it's hard to rule them out. I taught my my MD PhD students about the Bradford Hill criteria, which go through what are all the ways you can show that A causes B. And one part is correlational, one part is dose, one part is like the event, the environmental thing precedes the event of getting cancer. But there are other things like you can do experiments in the lab and show that if you put a bunch of this chemical, that the mechanism is one that is known to do something that causes cancer, like damage DNA. But it's, to your point, it's hard to be sure. One of the best studies I'm aware of, it was led by Dr. Laura Bean Freeman, who's a native of Iowa, but actually doing her research at the National Cancer Institute, where she looked at people who had the highest exposure of pesticides that were applied to chemicals or to crops in Iowa and North Carolina. And the interesting thing was the people who applied those chemicals had the highest exposure, but they didn't have the highest cancer rates. Now it turned out they smoked less than other people she was comparing to, so we had to take that out. But she wasn't able to detect higher rates. The other information we have that um, fits into this is you would expect the geographical or epidemiologic regions where the cancers are high to map to those agricultural exposures. And it's been hard to correlate that. if you look at the regions, the four increasing cancers in Iowa, prostate and breast are largely urban. Lung cancer is in the southern tier of the state where tobacco is more prevalent. The other one that's sort of interesting is melanoma, which is in the northern tier of the state. So that one, I think we could say there may be a question mark there.
Okay. And most of the theories are kind of a dose response, but there are some things that are a threshold response, and I just kind of wonder whether all of us, through the exposure we get, even through filtered or processed water, that the level could explain, that sort of a theory might explain why it's not just the farmers that are applying, but that perhaps the whole state is at risk.
Right. It's hard to know for sure, to your point. I think you're making some good points here. And so we can't say for certain how much that might be contributing. We could ask questions like, would it contribute equally in Minnesota? Would there be, and why is that different? Would there be some regions in the state that might be more than others? But one thing we are doing is we're assembling as I said, a blue ribbon panel to help us, get a more expert advice from advisors across the U.S. and internationally, who we are inviting to come, and to help us focus our efforts. Because what we don't want to do is take a sort of a guess that is, and spend a lot of our effort and money on trying to go on a wild goose chase. What we want to do is find the things that actually have the maximum impact and the information we can share to really make a difference in those cancer rates.
Right.
But we haven't ruled those out. We're gonna, we're turning up all the stones.
And to go back to something that's so important that you said, we do know some modifiable risk factors that are huge, and even when we educate people about them, getting them to align their behavior with the known science can be difficult. So
Well, that's why I appreciate what you're doing with Above and Beyond, because you're having a spin class after this, so you're having that impact.
Yes, and we don't allow smoking in our spin class.
Okay, good.
So yes, yeah, still keep hammering tobacco, obesity, healthy eating, physical activity, getting vaccinated for HPV and other diseases,
Right.
alcohol consumption, etc. Before we open it up for questions, let me give you the opportunity. Any particular topic we haven't covered yet that you'd like to talk about before we open it up to questions?
Well, I think, I just want to tell you the story of my, my stepmother, who asked me, "Are they ever going to cure cancer?" And I thought that was such an interesting question, and because it made me think very deeply. And I thought about all the patients who were cured with surgery and radiation many years ago. But then I thought of the patients whose cancer was controlled by Gleevec instead of a bone marrow transplant for 20 years. And then I thought of the Jimmy Carters who had, people like him who had melanoma that was going to be lethal and were cured with immunotherapy. But I see this, are we going to cure cancer, sort of as a long-term journey in this war on cancer, where we're sort of inching along. It feels like we're accelerating as we know more. But I think, I'm very hopeful and about where we are, and that in the next 10 years, we're going to be certainly ahead of where we are today.
Yeah, excellent. And and if we cured everything, including old age, I think pretty sure our planet would be in deep trouble. But maybe we're colonizing Mars by then.
Yeah, I don't
So
know.
I mean, so let me, because you're a real scientist, PhD. So I often answer that question like, no, I don't think we'll ever totally cure cancer, because inherently, isn't the blueprint for how we became humans is that mutations are an important part of life as we know it, and sometimes it makes us taller, smarter, and faster, and sometimes it causes cancer.
It is true that, you know, it is part of our very makeup that, you know, we are prone to cancer.
Yeah. Well, let's open it up to questions. So we've got a live studio audience, and Angelina has the microphone. She gets to go
Hey.
first.
So I'm a breast cancer survivor, 3 years. And
Congrats.
thank you. And it's interesting. I mean, I'm the only one that survived in my family of cancer. And so it's interesting how far we've gone in research and with chemotherapy and radiation therapy. But you kind of segued into my question. I said, is there any way moving forward in finding ways that will eliminate cancer ever forming in a human body, will, other than using drugs or therapy treatment? Do you foresee that in the future? I mean, there's 23andMe and Ancestry where they can check genetically, and it kind of gives you an idea that you might be getting cancer. Do you see something like that forming more in the future?
Yeah, thank you for that question. I think we are not going to be perfect in being able to prevent cancer, but we could do better. And so, for example, you bring up 23andMe or other gene tests. I think we could be a lot smarter about knowing, like assessing people's risks and screening appropriately. For example, mammograms now are recommended, depending on who you listen to, usually between age 40 and age 70. But if we were smarter about it and use those genes, we would find the people who maybe should be screened more intensely or earlier, and then the people who may not need so intensive screening and where we should be more watchful for other things. And so I think there are opportunities to do better. The other thing, and Dick mentioned this, there has been a lot of interest in what are called multi-cancer early detection tests. These are blood tests that can detect cancer with, you know, very early, and could in principle detect cancer DNA from any part of the body. Those are very challenging tests to design and develop, and some have been developed, but, you know, how do I say it? They're not sensitive enough, and if you screen a lot of people, you don't find cancer early enough to make a difference. And unfortunately, sometimes you think you found cancer and it's a false finding. So there needs to be more work done on that.
Okay, great. Thanks. Gary?
I'm thinking of our Governor Reynolds, in that at the beginning of her State of the State address, she was talking about cancer and the fact that we need to do more cancer research, and so as a result, allocating more monies to that research. And is that one of the programs that you will be looking at, or is that somebody else with that at the university?
Yeah, that relates to my colleagues who are part of the Cancer Center in our College of Public Health. What they are hoping to do is sort of do a deeper dive into the very local cancer rates around the state and how those cancer rates relate to other factors. So one idea is to go out to county by county or zip code by zip code, find out the rate of smoking, alcohol, obesity in each of those places, and try to estimate how much cancer at that level is caused by those factors. And then look for residual factors, like residual rates. So some parts of the state might not be well explained by those factors. And those are the places where we may be able to look for new causes, environmental causes, apply some of the ideas that our Blue Ribbon panel suggests that we should look very carefully at.
Great. Ron?
You mentioned bispecific antibodies. which I understand is very promising. Is that something that you're researching or doing clinical trials on at the U of I?
Both. We have a number of active clinical trials. There's a lot of investigational therapies being developed all across the world, and we aim to bring the next generation of therapies into the clinics and make them available to our patients and make sure people have an opportunity to participate in research on those next generation. We also have laboratories who are investigating that. George Weiner, who is the previous director of the original director, I should say, of the Cancer Center, his laboratory is investigating how to better employ bispecific antibodies for certain types of lymphoma. And then, as we go forward with this new research building, that is an area in cancer immunology where we have an opportunity to make material growth in and be sort of on the forefront of those technologies to control the immune system to destroy cancer.
Okay. And George, do we have a question from our streaming audience?
Yeah, Mary's watching on YouTube. She says, I appreciate that you converted from a Badger to a Hawkeye, number one, but your expertise is so needed here in Iowa. My dad died of leukemia in 1990, and my sister has colon and lung cancer right now. So I'm thankful for your passion in research as well as treatment. So that's more of a comment than a question. Now, I had a question when it came to medical research and cancer research in particular. It's been all in the news here in the first, part of this year. Our newly elected president, the alarmists out there anyway, are saying that he's intent on cutting back, if not getting rid of a lot of research funding. So my question is do you view that as realistic? Is there anything really that you can do about it? Are the folks there at the University of Iowa concerned about it? And what would it mean if on the presidential level that were to happen federally, if that money was withheld? How much of an impact would that have on you at all?
It would have an impact. So I think, there's a lot of concern and a lot of unknowns about what is happening at the federal level right now. I've heard a lot from my colleagues as well. The National Cancer Institute invests about $6 billion, maybe up to $7 billion now, in cancer research. A lot of that is allocated to various universities. So one of the things that we have here is the Holden Comprehensive Cancer Center that has been supported by the National Cancer Institute to allow us to serve the entire state, to have a clinical research program, to have laboratory researchers. It provides the infrastructure for what we do. And then individual researchers have to, fund their research projects, to pay for grad students, to buy the reagents to do the research. If the National Cancer Institute were defunded, that would have pretty severe impacts on the clinical research here in Iowa City, but also in Des Moines. I don't know if that's well understood, but there's a program there, an NCORE, that supports, I think, Dr. Deming, you're part of this team, and that supports clinical research and bringing those new drugs to many sites across Western Iowa. And I don't think that would be possible without that. The other thing it would do is sort of dry up the pipeline. I tried to project this idea of we're on this 50 years into this long-term war on cancer, if we want to use the Nixon era term. And we are starting to see material progress today for what we've learned about cancer 20 years ago. So if we stop investing in the laboratory research in understanding the fundamentals of cancer and cancer immunology, there's going to be, we're not going to fill that pipeline that would pay off in 10, 20 years.
Great. Well, thank you so much. We've run out of time. This has been amazing. We'd love to have you back again. My guest has been Dr. Mark Burkard. Mark is MD and PhD, and he is the new and current director of the Holden Comprehensive Cancer Center at the University of Iowa. Thank you, Mark, for being our guest.
Thank you so much for having me tonight.
If any of you that are watching this program know someone that would benefit by watching it, it will be available on demand beginning tomorrow at the Above and Beyond Cancer YouTube channel and also the Mercy Cancer Center website. I hope you'll join us again next week. Thanks, everyone.